Go ahead, read the question, try it for a while, apply all the methods you know. Okay, so I assume you have tried. Now I'm going to try to solve this. So in order to solve this kind of question, it would be a good thing if we shift everything to the point of view of the point P, so that we can describe the system much better. So let's try to shift C with respect to P. So we will be shifting C from the point of view of the origin to the point of view of P. And if you have a point x comma y, so it's described as x comma y when it's in the frame of origin. Now if we shift this to the point of view of the point P, then say it's now described as small x comma small y. The relation between these small x small y and capital X capital Y is that small x is capital X minus 1 and small y is capital Y minus 1, which means we can put capital X as small x plus 1 and capital Y as small y minus 1, sorry, plus 1 into this equation. So now let's do that. So this will be 4 times of x squared plus 2x plus 1 plus 2 times of xy plus x plus y plus 1 plus 3 times y squared plus 2y plus 1 minus 9 times x plus 1 minus 9 y plus 1 and then plus 8. This thing is 4x squared plus 8x plus 1, sorry, plus 4, and this thing will be 2xy plus 2x plus 2y plus 2. This thing will be 3y squared plus 6y plus 3. This thing will be minus 9x minus 9, and this will be minus 9y minus 9, and it's 8 of course. So when we add all of this up, you have 4x squared plus 2xy plus 3y squared. So I will just cancel these away so that we don't get confused. And then 8x plus 2x is 10x, but 10x minus 9x, that would just be 1x. And then 2y plus 6y is 8y, but then minus 9y, that's just negative y. And 4 plus 2, 6 plus 3 is 9. 9 minus 9, that's 0. And then minus 9 plus 8 is minus 1. So the new equation is 4x squared plus 2xy plus 3y squared plus x minus y minus 1 equal to 0. And similarly we can do this for this guy, which is 2x plus y equal to 4. So we will say 2 times of x plus 1 plus y plus 1 equal to 4, and that means 2x plus y equal to 1. So these two are the new equations, so the new curve and the new line. So what do we do after this? First of all, I'll move this to the next page. There we go. Alright, and now this point P has been shifted to 0 comma 0. Okay, now what we do is we consider say x1 y1 and x2 y2 to be the points of intersection of this line with this curve. Then of course it satisfies both of these equations, which means it will also satisfy any result of both of these equations applied together. So from that we can try to make these linear terms or this constant term into quadratic terms. So let's try to do that. So instead of saying x minus y, we will say x minus y into 2x plus y. Why? Because 2x plus y is 1 for these 2 points. So for these 2 points we can write it like this, and then for 1 we'll basically have this thing but square this thing, so minus 2x plus y squared. So notice that this will give you a second degree term, this will give you second degree terms, this is already second degree terms, and all of this is equal to 0. Okay, so 4x squared plus 2xy plus 3y squared, this thing will be plus 2x squared minus 2xy plus xy, which is just minus xy, and then minus y squared, and this will be minus 4x squared minus 4xy minus y squared. So 4x squared plus 2x squared minus 4x squared, that thing is just 2x squared, and then 2xy minus xy minus 4xy, that I believe is minus 3xy, and this thing is just y squared because 3y squared minus 2y squared equal to 0. Now notice that this thing is factorizable because we just converted everything to now second degree terms. We can try to factorize it. Before it was just kind of impossible to factorize it to homogeneous factors, but now we can do this, and in fact this will now give us like really nice results because this can be factorized as y minus 2x into y minus x. So either y is 2x or y is x. So this is a pair of straight lines, and this only works for these 2 points. So for these 2 points we have this pair of straight lines being true. So what that means is that these 2 points lie on the pair of straight line described by y equal to 2x and y equal to x. Okay, so what does that mean? We just shifted everything to p, right? And p is now 0 comma 0, and x1 y1 and x2 y2 are on one of these 2 lines, right? So what does all of this mean? Well, if they are on the same line, then of course the angle subtended, that would just be 0, but that would be when p is collinear with this and this, right? And the other case would be, so I'm going to draw this is our point p 0 comma 0. Now it's shifted to 0 comma 0, and this is say our point a x1 y1. This thing is y equal to x, and we also want y equal to 2x, which would be like this, and this is our other point b, which is x2 y2. So because these points are satisfying these equations, basically they are on these lines like described, and what that means is that the angle subtended by the chord AP is now just this angle, and we can find out what that angle is because now we know the slopes of these two. Now going back to our original axis and coordinates, you will see that this angle doesn't change, neither does any length, everything just shifts. So it's all shifted, but no lengths or angles are changed, and if we calculate the angle right now, it won't change, and then we can report that angle as our final answer. So how do we calculate this angle? This has slope 2, this has slope 1, right? So tan beta, where this complete angle with the horizontal is beta and this angle is alpha, so tan beta is 2 and tan alpha is 1, and we want this angle which is beta minus alpha. So what will be the tan of beta minus alpha? That is just tan beta minus tan alpha upon 1 plus tan beta tan alpha, but we already know these values, so it's just 2 minus 1 upon 1 plus 1 into 2, which is 1 upon 3, like this, and that means beta minus alpha is tan inverse of 1 upon 3, and that would be our final answer because yes, it doesn't change while going back. So that's how you solve these kind of questions where you have a non-homogeneous curve and a line, and you want to find the intersection points. Actually, you don't want to find intersection points, you directly want to find the angle subtended by the chord on some random point. So if I would have some other point, say 2 comma 3, then you would do the same kind of process, just taking 2 comma 3, shifting to 2 comma 3, once again making this thing into a second degree curve such that we can write it as a pair of straight lines, and then finding the angle between those lines, and we would be done. So yeah, I'll see you guys in the next video. Bye.